I was saying, guys, I need you guys to be paying attention. Don't have your laptops open. Don't have your earbuds in. Don't be talking to your neighbor. If I have to make seat changes, I will. I don't want to. I let you guys sit where you wanted to for a reason. I wanted you guys to feel comfortable in here. But you've got to let me do my job, which is to teach you. This is a speech I'm giving every class. It's not just you guys. Okay? I think we're just getting really comfortable in here, and I want you to be comfortable. But I would really prefer that you guys not get up and go to the bathroom in the middle of the notes. If you really have to, of course, I'm not going to tell you you can't. But it's all the constant having to get up and open the door and, address stuff it just think about your classmates that are here paying attention and want to get through the lesson so they can get their homework done. That's our goal. I want to give you as much time not listening to me, not me sitting here, but you guys working, okay? So I think I do a really good job, or at least I think I work really hard. I know I work really hard of dissecting every lesson, only doing the examples that I think we have to do. You guys see I skip around. The homework assignments are always broken up into chunks because I do respect your time and all that stuff, but every time I have to open the door or tell somebody to wake up or, close your laptop, it just takes time away from everybody else. So that's all I was getting at. So let's get started. If you were here yesterday, you're going to almost think that this is the same lesson. We'll be able to skedaddle through it pretty quickly because it's almost identical to yesterday, okay? But instead of arithmetic being like linear functions, we're doing geometric and exponential functions. Oh, one more thing before I start. Don't forget Monday is a work day. If you've been absent this week, it's a great day to watch videos, work on notes, homework. I'll open the quiz that day as well, and you guys can work on the quiz in class. It'll be open Monday through Friday. Okay? So bring your laptops on Monday if you're going to work on the quiz. Okay, so here's the thing. Yesterday we talked about arithmetic sequences being like linear functions. They had a lot of the same properties. Same with geometric functions, have a lot of the same properties as exponential functions. And we haven't done exponential functions in this class. They're very easy to work with. You did do them in Algebra 2. We're going to just touch on them today. Really, really, really easy. And then we'll dissect them much deeper later in this unit. But exponential functions are in this form, a times b to the x. And sometimes we use this notation just like yesterday. Okay? And I will break that down for you more when we get to where it applies. But I just wanted to tell you about that. The graph of an exponential function looks like a J or a backwards J, kind of like this. So you'll see it looking like J, a backwards J. So it curves versus yesterday, arithmetic and linear were lines, right? Made a line. Okay, so we're going to use this graph of the sequence to complete the table. And if you look, if you look at what the points are here, it would be really hard to pull the points off the graph. They're not exact, and it's not printed very well. So we have mathematical ways that we can figure out this table. So it's telling us this is a sequence. By the way, it's a geometric sequence. Now you will know that going forward because it's curvy versus straight. That tells you it's geometric. So what we're doing in this chart is multiplying by something. Okay? So to find your R, remember, R is what you multiply the common ratio throughout the chart. You would do the second minus the first, or any two consecutive. So you have 32 over 64. Put that in your calculator, and you get 1/2. So R is 1/2. So you can see it makes sense. These numbers are getting smaller. When you multiply something by 1/2, you're dividing it by 2. So easy to just finish the table. Okay? Well, we found the common ratio, and now let's write the explicit rule. As a reminder, you might have it memorized, but it's been 2 days since we used it. The explicit rule for a geometric, or I'm going to put, what did I write? EF, explicit function, rule, whatever. A sub k, no, that's an n. Sorry, change it to an n. A sub n equals A sub k times r to the n minus k. So that's the formula we used a bunch last week. And so we're going to write that function right here. And as I told you before, what we've been talking about with arithmetic, a sub k is your choice. But for geometric sequences, let's try, if it's available, to use the first term. That way your answers will match mine. Your answers will match multiple choice. Technically, any of these could be a sub k, and you get the same answer in the end. But it's just good practice to use the first term. Okay? So a sub n would be 64 times, and you can use the dot or the parentheses, and then n minus, and since I used the first term, my k is 1. And remember, geometric sequences are easier, in my opinion. You don't have to do any simplifying. That's it. That's the function, right? Now, just like yesterday, we did the explicit function for arithmetic, and then we wrote it in slope-intercept form. We're going to now use the information here to write our exponential function. So there's a couple differences, okay? Here's the thing. When we write a function, we write the information as an exponential function. We're going to use this f of n business. I'm going to put a little bit more detail here. And you know how I just wrote a? That a value is always a sub 0. It is always the 0th term, okay? And then your b value, it is the same as r. B and r are the same number, just like m and d were the same number yesterday. And big difference here is that we only have an n, not an n minus k or minus 1 or anything. It's just an n. So when you write the explicit formula, you're always going to have minus whatever the k is. Exponential, you will not, okay? And this has to be a sub 0. The number that comes after the equal sign in these functions is always your y-intercept. Remember that? X is 0, y is your y-intercept. So what do we need? What do we have? Well, we need a sub 0. We have b, right? b is 1/2. But we practiced this before. How do we find the 0th term if we don't have it? Just use your math that you did here, but go backwards. So here we were basically dividing by 2. Going the other way, we would multiply by 2. So 64 times 2 is 128. And there you go. Write your answer. F of n equals 128 times 1/2 to the n. Now, even though they look a little, I mean, they both have like a base and a power, just two numbers down on the ground kind of thing. They do look a little different, but if you take a second and just think about it, these are the same. Because if you plugged a 0 in for n, so if you wanted to find the 0th term, you would get this. Wait, that's not what I was going to say. What was I going to say? I don't know what I was going to say. These do mean the same thing, though, because this, if you subtract 1, you would go backwards. You get the 128. This is just, you'll never put a number on your exponent. I'm not sure where I was going with that. Oh, I know what I was going to say. The way we did it in the chart was fine, right? But you also could have plugged 0 in here. That's what I was going to say. So you could have plugged a 0 in here to find your 0th term. Remember, that's what an explicit formula is for, is to find the nth term. So if you needed the 0th term, you have more than one way you could have done it. In that example, anyway. Okay? All right. This looks familiar. Given the geometric sequence, they gave us the first term and the third term. They're telling us it's geometric. We learned something the other day about how to find what's in the middle. Yesterday, we had 2 points. We used our slope formula to figure out what we were multiplying by. Here's where we can use our geometric mean formula. We will do the square root of the product, let's multiply, of these two numbers. That will give me the second term. 144 times 36 under the square root is 72. Well, how did that help us? Because we can't do that anywhere else. Like where else? I mean, I guess you could do this one and this one and get that one, but that's way more work than we have to do. Anybody have another way of doing that, doing this problem? How can I finish this? Yes. Who dat? So R or B, whatever you're calling it, remember, it doesn't matter. You can just take any two consecutive ones, 36 over 72, 72 over 144, put it in your calculator, math, enter, enter, and you will get 1/2 again. So remember, multiplying by 1/2 is the same as dividing by 2. So we would get 18, 9. And guys, when you start getting into fractions, think about how easy this is, because we're going to see it again in a minute. 9 times 1/2, think about it, that's 9 halves, okay? 9 halves times 1/2 is 9 fourths. The next one would be 9/8. The next one would be 9/16. It's a nice quick way of doing this without having to pick up your calculator. All right? And example 10 is, let's take this information. Oh, forgot, domain and range. Domain and range. I didn't mean to use that space right there. We don't need to write it out. The domain are your x values, range are your y values. Even though they're calling this an explicit function, we now know that these are also just ordered pairs if you graphed them. The first term is 144 at 144. Okay, your domain is those numbers, right? Sorry, those numbers. And I feel like I didn't say this in this class yesterday. So you list out your domain, 1, 2, 3, so on, right? Range would be 144, 72. You would just literally write them out. I'm just saying, why would we spend all that time doing that? What you will not do, this is important because I feel like in this class I didn't say it. You would not do this. Okay? The domain is not from 1 to 7, inclusive. That's how you would say that. So from 1 to 7, including the 1 to 7. Because when you write something in interval notation like this, you're saying every number in between. Are we in a geometric sequence including the numbers between 1 and 2? The answer is no. It's just 1 and just 2. That's why these points are not connected. That's not a typo. That's not a, oh, we should have filled that in. That's what it should be. It's just 1, just 2, just 3, and just 64. So it's not the numbers in between. Now, in an exponential function or a linear function, yes, we would connect it with a continuous curve or line, arrows on the ends. That's the one difference really between the two on both sides. All right, so now let's write an exponential function. Okay, exponential function, I need a sub 0 and b. I know b. B is the same as r. Easy peasy. I need a sub 0. Just go backwards, right? So we would multiply by 2. 144 times 2 would be 288. That's everything. That's all you need. Again, don't forget, there's no minus anything up there for exponential. Okay. This next example is going to look familiar. Okay, look at this graph, curvy. You know that now, from what I told you, that this is exponential. It's not connected, so it's a sequence, geometric sequence. They gave us the values here that are graphed here. A sub 1 is 3, so there's a point 1, 3. And then 2, 6. And 3, 12, 24, 48, 96. So I just pulled them right from here. And again, this is just making sure we understand subscript notation is when we're doing like our explicit formulas. When we're talking about sequences, that's when we use this type of notation. And function notation is what we use in algebra, like linear functions and exponential functions. Should I put here? Let's put. So that's f of 2. And you guys know this. Whatever's in the parentheses is your x value or your input value. So just several different ways of writing the same information. So let's write this sequence in both its explicit formula and in the algebra version of it. Okay, so you don't have to write this again if you don't want to. A sub n equals a sub k times r to the n minus k, right? And this one is f of n equals a sub 0 times e to the n. We're really using the alphabet these days. We're really using it. Okay? Subscript notation is our explicit formula. Let's do it. A sub n equals, and like I said, we're going to try and use the first term, if we have it, which is 3. What is the r value, guys? What is our r? Yeah, we're multiplying by 2 the whole way down. So r is 2, which means b is 2. We're going to need that in a minute. And then n minus, and we use the first term, so k is 1. And there's no simplifying with these. That's why we like these better, typically. Okay, so for function notation, few changes. We need a sub 0 instead of a sub 1. You have choices. You can plug a 0 in right here and simplify it, or I think it's easier to just go to the table and work backwards. What's half of 3? 1.5, 3 halves. You can use either one. We don't really use mixed numbers very often. Although 1.5, like I wouldn't mark it wrong, you're never going to really see that. In math, and especially algebra-based math classes, we always want to use the fewest amount of symbols as possible. Okay, so 1.5 is bulkier than 3 over 2 or 1.5. So it's not wrong. This is just better. Okay, or 1.5. And we have a 2 and n. Don't put a -1. That's a common mistake. So just kind of get this and this in your head. Those are the two formulas, right? Everybody good so far? Okay. Given an explicit formula, I know what that is. I know what an explicit formula is. It's used to find the nth term. Oh, it didn't say what type it is. Is it geometric or arithmetic? Oh, I know. It's geometric because it's got an exponent, right? That's how you would tell the difference if they were mixed together on a test or something. If there's an exponent, that's geometric. Okay? Quiz is open note on Monday, so you would have all this stuff in your notes. Write the first 6 terms of the sequence. Okay, so the definition of an explicit formula is used to find the nth term. I want the first term, I can plug a 1 in here. 1 minus 1 is 0. Anything to the 0 power is 1, and 1 times 6 is 6. My first term is 6. And I didn't show the work. I did it in my head or on my calculator. You could have written it out, but all I did was plug in 1. Now, I could plug in 2, and 3, and 4, and 5, and 6, but that's a lot of work. What another thing about geometric sequences that is nice is we know, because there was no simplifying thing about when we create these, we don't simplify it. That is it. We know that's the first term. We know that's the B or R. So we know that we're multiplying by 1/2 the whole way. I don't need to do anything else except keep dividing by 2, right? Multiplying by 1/2 is dividing by 2. And let's use that little trick I showed you before so you don't have to do much work. Half of 6 is 3. Half of 3 is 3 halves. Then it would be 3/4, 3/8, 3/16. 1, 2, 3, 4, 5, 6. It works just like that. It's very nice. Find a sub 0. So this guy is a sub 1, so this guy is a sub 0. Again, you could plug 0 in here, or you could just work with your numbers here. So what would a sub 0 be? Well, double it, right? Divide that by 2, divide that by 2. And last, write it as an exponential. Okay, that means I need a sub 0. Got it. I need b. Got it. See how easy these are? I think these are easier than what we did yesterday. So f of n equals a sub 0 times 1/2 to the n. Don't subtract anything. So I had a decision to make on this Friday. Do I keep going in the notes with the word problems? Or the better choice, which is what I've decided to do the last two homework problems with you, which are the word problems. Okay? So there are times that I want to cut the notes a little bit shorter, and I might do some of the homework with you, which will just help get through everything easier and not have me sitting here talking to you too long. Last year I taught this class 6 times a day. That was my whole schedule. I only taught this. I was like losing it. By the time I got to like the 5th and 6th time, I was every day saying, I don't know if I said this already. I don't know if I said this already. I was kind of losing it. So I'm going to do 11 and 12 with you. So after you write this down, please go to page 25, and you want these word problems done together, okay? So even though you like to start with number 1, just do 11 and 12 with me, because you're going to have to do them anyway. And I did this to benefit you so that you don't have to sit here much longer. All right, 11's super easy. 12 has a couple of tricky things. All right, number 11, Geo. A culture contains 10,000 bacteria initially. Guys, this word we are going to hear all the time. Initially means at the beginning, before time starts. It's your starting amount for your A sub 0, also known as your y-intercept, okay? And increases by 20% every hour. The minute you see a percent symbol in a word problem in this unit, it's going to be either geometric or exponential, okay? So we know that we're going to get our B or R from the 20%, okay? So find a formula for the N of T of bacteria after T hours. So which formula is that? That's going to be the exponential one, okay? Because it's function notation, f of x, f of n, n of t. So this is going to be an exponential function. What do I need for an exponential function? A sub 0. There it is. And B, which is the same as R. So remember, there's work to do with percents. 20% must be changed to a decimal first. So you either move the decimal point 2 places to left, divide by 100, figure out what you need to do, and you would get 0.2. Can you write the 0 after that? Of course, 20% or 0.2. Either way, 0.2 or 0.20. But don't forget, 99% of the time, there's one more step. If we're increasing by this every hour, we have to add 1 to this. So our B value is actually 1.2. Think about why. It takes the whole thing and then adds 2% onto it. And then the whole thing after that next hour adds 2% to that, right? So now we have the 2 numbers we need for this formula. N of T equals 10,000 times 1.2. What exponent will I use here? T, right? This is my input, should match that. How many bacteria in the culture after 10 hours? I don't think any of you would get that wrong. The only thing I would caution you guys on is make sure in the given information and what they're asking, the time matches. Like it doesn't say days here and then hours here where you'd have to convert something. This wasn't like that, so T equals 10. So for time's sake, I already plugged the 10 in here for you, and we get a crazy decimal, which we will round to 3 decimal places. Okay, number 12, and then I'll shut up, but there is just a couple little things we have to talk about in here. Are we good with 11, everyone? A rubber ball is dropped from a height of 25 feet. The ball bounces to 80%. Okay, so right away I know it's geometric, exponential because of the percent sign, and we are going to set up a little table of values to represent each bounce. So it's dropping from a height of 25 feet. Is that my one value? No, Michael, it's what, Michael? 0. Yeah, guys, they try to trick us. They didn't say initial, but think you have to actually picture it. You're on a 25-foot ladder. I don't know. You're 25 feet tall. I don't know. The ball is 25 feet in the air before time starts. Then it drops, okay? And it drops to 80% of its previous height. Well, that's what we're going to get our R or B from. You always have to change the percent to a decimal. Divide by 100 or move the decimal point 2 places. Now, this is tricky. Be careful. This doesn't say the ball bounces 20% less each bounce. It's telling you it's only going to go up to 80% of the previous bounce. The math has already been done for you with the plus or minus 1. So you have to really read it carefully. So that means I'm multiplying each of these by 0.8. I did it for you. I'm just in my calculator doing 16 times 0.8, 12.8 times 0.8, and so on, all the way down. If I ever have to round, it's 3 decimal places. Makes sense. It's getting smaller. Okay. Write an exponential function to represent the height of each bounce. Okay, f of n. Remember, in these functions, it doesn't say a sub 0. We just know now a sub 0 is what we use. Okay, I'm going to tell you something right here that I want you to listen to because it's going to help you on your quiz on Monday and on so many things we do in here. These last 2 questions. What is the height after 10 bounces? When will the ball bounce less than 1 foot high? Listen to me right here. Height is y. So, what is the height after 10 bounces, right? Have x, need y. We can just plug right in, right? So, plugging in n equals 10. I did the math for you. 0.8 to the power of 10 times 25, you get 2.684 feet, okay? So, fine, easy, right? They give us different n values, we plug it in, whatever. Use our calculator. But this is important. Listen, listen, listen. When will the ball be less than 1 foot? We need x and have y. This is the one. When you have y and need x, anytime you need x, we use the intersection of our calculator. You have to. We haven't learned how to solve for an exponent yet. When we get to logs, we could. I could put 1 right here, and I could show you how to divide by 25, and then get that n down on the ground by using logs. We haven't learned that yet. So this is quick and easy, guys. Go to your calculators. There's a question on your test that you have to, your quiz on Monday, that you have to do this. So that's why I'm making a big deal out of it. So I would just type in 25.8 to the x, and y equals 1. Remember, we had it on our last test, where there's a horizontal line, and you just find the intersection, and that will give you the x value. So graph, and you can see there's that J-looking graph. There's my horizontal line. I can see that the intersection is to the right somewhere. So I'm going to go to my window, change my x max to, I don't know, 50. X max moves us to the right. And as long as you can see intersection on your screen, you're good. And intersection is the easiest of all of them. You never even have to use arrows. Watch. Second calc number 5. Wherever the cursor is right now, just hit enter. When you hit enter, your cursor will jump to the next graph, which is the horizontal line. Enter, it jumped, enter. It's always going to ask for a guess. Yep. And then, so you just hit enter 3 times. Intersection is the easiest one. Enter, enter, enter every time, you'll get your answer. And so that's 14.425. Okay, so this is what the calculator gave me. We want less than 1. How many bounces would that be? I got this wrong. I got this wrong for the last 3 years until someone fixed me last period. I have no problem admitting when I'm wrong. Think about it. How many bounces are we going to be less than 1? Because right now, this is exactly 1, 14.425. Are we going to round to 15 or 14? Which one? Yeah, you guys said it right. I got it wrong. Because the more bounces, the lower you are, right? As we go through, the 15th bounce is going to be less than 1. At the 14th bounce, we're at 1. I'm probably not saying that beautifully, but hopefully you get the idea. But know when to use intersection. When you have y and need x. On the quiz. Mm-hmm. Say it again. So did you type them both in first?
Yeah.
What's all that other stuff? Okay, you need to clear your name. And you would type in. So type in the first equation. Okay, and then the y equals 1. That's the height. I just want to say 2 in both of them.
So y equals 1, yeah. Oh, I get it.
And then you find the intersection of that curve and that horizontal line.
Huh. What I was doing was I made it so that it equals